Hello everyone. So in this video, we are going to move on to a totally completely different topic, which is subjectively, where is it here? Here. Subjectively estimating the demand curve or subjectively estimated demand curves. We're gonna use the quadratic or polynomial trend line so that we'll be able to get a demand function. In the previous exercises, we were able to get a demand function by getting the current state kind of point, knowing the behavior, linear here or power, elasticity, and once we get the elasticity and know it's linear or power, we'll be able to get a certain function for the demand. Now, what if we don't know our elasticity? If we don't know our elasticity, we will need 3 different points. And in the question, let's read the question together. So the question is, where is it? Here. Suppose that a drugstore pays 0.9 for each unit of chapstick. So this is the unit cost. The store is considering charging from 1.5 to 2.5. So this is the maximum and this is the minimum. So I am constrained by the minimum and the maximum that I could charge as a store. It thinks that at a price of 1.5, it can sell 60 units per week. At a price of $2, it thinks it can sell 51 units per week. And at a price of 2.5, 20 units per week. To determine what price that the store should charge for chapstick, we need to do the following. First, we're going to put a lineup, or we need to line up the prices associated with a certain with its corresponding demand. So we will align 1.5 with 60, $2 with 51, 2.5 with 20, and put them, as you can see here, on our Excel. I think this is, sorry, 45. So all this is supposed to be 45. It's given in the question here on slide 45. Okay, so now we have these 3 points. What are we going to do is we are going to not select point 1, point 2, point 3. However, what we're going to do is, and we also added this unit cost, right, which is 0.90. Now we are going to select the price and the quantity, as you can see, without these points, and we're going to insert here the scatter plot, and basically we don't have to change any rows and columns. We add the trend line. Oh, it's linear? No, it's polynomial of order 2. Why is this so? What is the polynomial of order 2? In fact, in mathematics, as you can see, a polynomial curve is more of a subjective representation of the price versus demand. And this quadratic equation, you always have it as y, or demand, is equal to some constant a times the price squared, or x squared, plus bx plus c. So that's quite interesting. And you need 3 points. So you need to experiment as an e-commerce, for example, entrepreneur. You gotta a little bit experiment with this kind of pricing and see, when I price as 1.5, what happens? When I increase the price, what happens? When I increase the price further, what happens? And then you basically need to draw this trend line. And of course, you need to display the equation. This is what you need, the demand function, because in every optimization problem so far, we always used demand as a function, right? So now this is our demand function. It is minus 44 times price squared plus 136 times price minus 45. All right, so having this said, here is our, I already plot that. So here is our demand curve. What we are going to do, we are going to set up the optimization problem. So we have over here, we need the optimal price. So this is usually the price of a chapstick that, so price of the stick. This is the price of the stick. And then you have also the demand. And the demand is going to be equal to minus 44 times this, the price of the stick, to the power of 2, plus or minus, plus 136 times price minus 45. And that would be the demand function. So over here, this is the decision variable, unknown, because I need the computer to develop it, to find it, generate it for me. This is the demand function. And now, what is the unit cost? So we have a unit cost of the stick to be 0.90. Very good. And now we are ready to actually compute the profits. So the profit, it's going to be the demand over here times, the demand over here times the price that we need the computer to find out what is it, minus the cost. You can see that I didn't name anything right now, but of course you are welcome to actually name any of these as you wish. So here, formulas, create from selection, left columns, okay. So now this is called the price stick, demand. Maybe I should put demand stick, maybe, right? Yeah, okay. So this is equal to, again, the demand of this stick times the price of the stick minus the unit cost of the stick. This is not a must, really. Uh-oh, what did I do? Okay, so now we are ready to rock and roll. But there's something we need to add here, a note, that the author said that the shop owner is willing to charge from, or is considering, the store is considering to charge between this and this for any unit of a chapstick. So this note is very, very, very important, isn't it? This is a very important note, and maybe we make it a little bit okay. And this note is actually the constraints in the optimization problem. So these are the constraints of the optimization. So these are the constraints of the optimization problem. Let's begin. So we're going to have data, we're going to have solver, and then we're going to have profit, and then we're going to have max, changing this, and we're going to add here subject to constraints. So we're going to add this subject to constraints. We're going to have this price to be greater than or less to 1.5. And also again, we need this price to be constrained to be greater than or equal to 2.5. So we have 2.5. And then we hit OK. And now we can solve. And when we solve, we're going to get 32 in terms of profit. So if we charge 2.5, we're going to get the 32 profits by selling a 20. And well, this is a very interesting example here. Wait a minute, let me add this insert here, something interesting. Just for the fun of it. Okay. Put these back. let's compute the profit here. So if I compute the profit over here, it's going to be the quantity times the price minus the unit cost. Yeah, so unit cost is not going to change it, so we're going to stabilize this cell, and it's going to be the same. So we're going to actually hover over until the cursor changes from a fat white cross to a skinnier black cross, and here we go. This is the quantity or the demand times the price minus unit cost. Okay. So this is the profit. So in fact, there's something is wrong here. Maybe, did I put here 2.5? Less than, greater than. You see what was wrong? Oh no, it should be less than or equal. I'm sorry, قُمِنّي. I thought so. So this is the price is greater than or equal to 1.5, which is the minimum price, and less than or equal to 2.5, right? So I thought something is up. And here is okay. And now, as you can see here, you will, sorry, قُمِنّي, I'm really sorry for confusing you. Hopefully you picked it up as I'm doing it. So here we will have the price should be around $2, so that it's the 2.04. Okay. What if I actually put the price as only 2? Oh. What if I just use the 2 here? There's gonna be 56. Yeah, because in fact, when we are gonna price, we're not gonna price probably 2. We're gonna price 1.99 because of the psychological pricing rules in marketing. Based on psychological studies or psychology-based studies or consumer behavior related studies, we find out that when you price, when the price tag is 1.99, people are more keen to buy. So you probably might even make more profits at certain times, and get your demand faster to jump to a certain level. So in any case, this is what the result says. If the result says 2.04, something like that, will get us something around 56.24. So roughly, that is a very interesting. Let me just run the optimization problem again, so that when I share the file with you. Okay, all right, now it's all good. And this is how we do this optimization problem based on subjective pricing. So now, what is next? Next is the assignment. I would like you, I'm gonna put an Excel sheet for you to work, and it's gonna be exactly the same question, but I am going to change the elasticity, for example, to 3, higher elasticity, or 2.5. So I'm going to put the elasticity to 3. And over here, I think this is probably very easy optimization problem, but I'm probably going to put the probably I'm just going to give you just 2 questions, one for the razors, exactly the same like this, and I'm going to ask you to do all the steps that we've done here. You need to do exactly the same steps, but with a linear elasticity of 3 rather than 2. Thank you so much, you guys. Take care.